Hello. Yeah, thank you. So who am I? I'm Nick Denny. I'm a VP of Engineering and co-founder of a startup called API Metrics. We do API monitoring. So if you do have APIs, please do monitor them. That's my only plug there. I'm not talking about APIs tonight. As you can tell, I'm from Seattle. I may have dual citizenship. I assume that being half British and half American makes me Canadian. I don't know. I'll tell you the border guards didn't agree, but they let me in anyway. So, let me take you back to the distant past. It was 2009. I was working on mobile apps. I wasn't writing Python. I didn't know anything about databases, really. I'd scraped through that course at university. I didn't know anything about DevOps because I was writing mobile apps. We just deployed some code. Well, we just compiled some code and sent it to Apple or Google or whoever, and they just sent apps. So that was fine. So but I needed to write some server code, and luckily there was something called Google App Engine, and they woo indeed. They have and it runs in Python, so I had to learn Python, and that was fun, and it worked, and so in Google App Engine, they have something called the Google Data Store. And so you can create objects and store them and use this sort of format of class. You define some properties, and let's scroll grid, and it seems to work. I don't really worry about how it works, but it just works. And then if you, so this is called an object relational mapping, or ORM. And so if you want to store the data, you create a new object, and you set the attributes, and you call put, and you store it, and that's great. All very simple. And then if you want to get the data out again, you call a query method, and then you can edit query and fetch it. So that's pretty handy. And so that's in Google App Engine, and I believe Guido himself worked on some of that code there, so that was pretty cool. I thought, oh, great. A lot of you probably don't use Google App Engine, but you probably have used SQLalchemy, and they have the same idea. You don't have to use it, but there is an ORM, and you define classes with your column names, and that defines what your data looks like. It's all very simple. And then similarly, you have a query, you filter it, you get results. Great. But I'd just begun using Python. I didn't really worry about it too much, but what is actually going on here? Look, you go back to this filter. We've got the query filter. Let's do some CSI here. So we zoom and enhance a bit. Oh, wait. Remember what your slides are. What's going on? I don't know. Zoom and enhance. Right, it's a filter. And there's a movie.title. And that's like a class to a property. And then there's equals. Equals means something. It's a mathematical thing. Why is that property equaling a string and then passing into a function? How is that even going to work? Like the pure mathematical nature of it does no longer work again. What's happened? I mean, the movie's been out for a while, guys. So, what happens? It's actually magic methods. And they hold together Python. This is how you take advantage of a lot of the power of Python. I like to think of the magnets of Python. So magic methods, how do they work? So these are all these functions you probably have seen you can define in your classes, underscore, or dunder. So dunder init, you probably use every day. A lot of these other ones you may need once in a while. And there's a lot of them. So this is all to do with classes. And if you want to be a container, you can create yourself something that acts like a dictionary using these, or like acts like a list. And there's context managers. I believe Guido mentioned it started in 2.4, so you have the enter and exit. So you can use the with statement. And you have coroutines, so you can do async kind of stuff. And then there's mathematical unary operators. So these are things you do to yourself. Phrasing. And the comparison operators. So this is dunder LT is less than, so you can call less than. LE is less than equal to, not equal to. I think you're getting the idea, right? Magic methods. And there's arithmetic operators, so these, even more of them, and actually even loads, because there's the R version and the I version of all those as well. So let's just have a quick look at some example code. Pretty sure that works. So you have a class, it has a value, and then let's have the add and the R add, and just do a print statement to see what happens. So we have A and B. We call A plus B. So what's it going to print? It's going to print add A. So it's not called the R add of B. It's just called the add of A. And then 1 plus B. See where R is coming in here. R add B. So because the 1 didn't know what to do with B, the R add get called. So in conclusion, writing A plus 1 is actually the same as writing this function A dunder add 1, and 1 plus B works out to be B dunder R add 1. So these methods you can override are very powerful. I would say usually you would not be calling them directly yourself. You override them to let you have behavior, but you don't want to be sort of calling into the innards of it, because they're kind of sort of private, because they're underscores, basically. Underscores are private, right? That's how it works. So the reason I'm here is because I went to PyCon in Portland 2017, and one of the talks I was really inspired by was by Sepp Depor, and he gave a great talk about how magic methods work and went into a lot more detail about than I've just done. And just to show you sort of the crazy things you can do with them, he created this library you can pip install called Bad Ideas. So this is, so you can create a number object which is mutable. So when you do 3 minus the number, it actually removes 3 from the number. It's a terrible, terrible idea, and it would cause a lot of confusion if you ever used it. So I recommend you go on YouTube and watch that talk. And another part of his bad ideas, he managed to use them to create a grep and a bash-style piping by overriding the logical OR. So it's pretty, that actually almost useful. It's not very Pythonic, but sure. So I'm going to go you to a real-world example where we take advantage of this kind of stuff. Apache Beam, which is to do with pipelining big data, they have created code that looks like this, which I think might be a bit much, but you can see here they obviously got the enter, dunder enter for the with statement, and they've got an OR for the P OR, and I think it's probably an R shift from the result of that function to give it the string read. I think this is Python being used to fit a different paradigm. I'm not really a fan of it. Right, so quick aside. As I mentioned, PyCon 2017, there were 2 talks about dictionaries I really liked as well. So these 3 talks combined is kind of why I've got to this talk. And so the 2 talks, one by Raven Hettinger, one by Brandon Rhodes. So they were good talks. And so how do dictionaries work? Is a bag of dictionary with names in there actually just a list of tuples? Well, no. So how do they actually work? Well, I've got a useful side here. They use hashing and buckets. Are you hungry yet? It's nearly lunch, right? So, in fact, when you store the data, it's like a long list. And before 3.6, with gaps in, and you'd look into these buckets to find the value, so it could be quick to look up. And now in 3.6, you get rid of the gaps and have a separate index list. And this means that dics in 3.6 are actually smaller than ever before, use less memory, and they're still very quick. So this is really great. And so in his talk, Raymond Hettinger had this great line, which was, with all our work in dictionaries, we've reinvented what was done with databases long ago. So basically how dictionaries work is kind of how databases work, like a SQL database. And that got me thinking. And I'm sure you're all thinking this too now. No? Come on, audience. Just a few more minutes, I promise. So no, what I was thinking was, well, if a dictionary is kind of a database, shouldn't we have some kind of ORM? So I admit this is probably as equally valuable as the bad ideas pip library, but let's just see how does an ORM work by using a dictionary. I'm going to call it a dictabase. So first start, we have a model. And to help you all out, and so if you don't really like the rest of this talk, I'm using example data of Facebook search of places to eat nearby here. So at least you might find something useful to you. So we have a model class, and it's defined the same way. We have these properties. I'm not going too much into properties, but so we defined what our data looks like, basically. And then a data set. I could load this from a CSV or something, but just now it's just a big list with lots of instances of these models with the different things, and it's got the rating and the street and things like that. So what is our interface going to look like? I'm going to start with the interface and then work to how it's made, how it works. So I've decided we're going to say with, and this database, we're passing in data, we're going to query it, we're going to filter it, we're going to fetch some results. And how am I going to do this? Well, apart from this defined interface here, it's all going to be magic methods. No other functions. So here we go. Dictabase is what I'm sort of the parent of everything here. Doesn't actually do a lot because, as you saw, I was creating it and immediately calling with. So actually what it does, it just gets the data and the index and creates this helper class view, and then the enter will be returning it. So that's fine. So we have the index class. So because in a database, you define your indexes, and that's how you can query things quickly. So the index is a list of the attributes we're going to index on. So the index class looks like this. I'll go into a bit more how this works in a second. And then the view class. So this is actually where the main bit, because this is getting the data and the index and putting them together. So what's a view? It's a subclass dictionary. We have our dictionary. And I've got my init, and it so just overview. We're sorting some data, and we're putting it inside our dictionary. And I'm running 3.6, so it maintains order. So this is perfect. This will make sure the data is in the order we want it, and then later we'll be able to call query. So let's dive in a bit deeper in how this works, hopefully without losing you all. So I said we start off calling the database, passing in data and index. Calls the init, done the init function. And then we call into the view. So look at the view, sorted, and then adding to itself. What's happening in the sorter? Sorted, the key parameter is expecting a function, but we've passed in our index class. So as you might imagine, that means that we've got a call method on the index. So this index class instance can run as if it's a function. So this is the sort of clever bit, I guess. So how is this working? The keys and the model we have. So the keys are what we're indexing on, and the model is the data. So what's happening here is we're pulling out the specific values we're indexed upon, and we're returning a tuple. So if you pull this data out, what are we actually getting here? We're getting 2 values and a string. So why am I using a tuple? Well, tuples are unmutable, which means they're hashable. Hash. Now I'm getting hungry. So when we set ourselves the values into the thing, we're using the key is the tuple. So normally you'd think of them, normally a dictionary, you probably think, oh, I'm passing in strings and accessing things like that. But it can be any object as long as it's unmutable and hashable. So now our data is in the right format. We've got this slightly strange thing of tuples being mapped to models. And it's keeping in the sorting, because I said we're running 3.6, and it's added in order. So in the sort of world of C, Python, or something, the memory would look a bit like this, kind of vaguely. This is working like a database. So we're using indexes and hashing, and these are the buckets. So this is what we wanted. So we got the data, and if I just went through the results there, it would just be all the data in order. But we also have a query interface, so how are we going to get the data out of there? Well, we've got the nice ORM, so the query function. Basically, we have some statements, and we have a filter thing, a function which returns a new query. So queries themselves are unmutable. That was just a design choice. That's what a lot of the ORMs do, so I'm following that pattern. And we've got a fetch function, which I'll cover in a minute. So what happens? Query.filter, model property is greater than 2. How is this going to work? Well, if you go into the property class, discover, oh, look, here's all our magic methods. And they're overriding them. And what happens is we're just storing the values we know about ourselves and passed in and creating a statement class. So we're not doing anything apart from returning a statement. So when we call this query.filter, it's actually getting passed in a statement which stores this state, basically. And what's the statement look like? Well, it's just data, and there's a call function, which I'll get into in a minute, because we need it in the fetch. So the fetch, this is where we do all the work. We go through our items, just using the .items, keys and values, and we go through each statement, and we call that statement, passing in the data, and if it's true, we add it to our list of results, and as long as they're all true, because I've defined that if you have 2 filters, it's an and, you get appended. So key, value, items. Pretty simple, which is iterating through. And then in the statement, we're going through each statement, and we call the statement. So we're back in this call function here, and really the key thing is here, because we stored the attribute name, we can then get the function name. So the getAtta here is actually getting the dunder LE or GT method for the value, the object you passed in. So here, this will be a string comparison or a numeric comparison, depending which item, and we're just returning, then calling it. So we've used all this to delay calling less than on a string, because we didn't know what the string was when we first called it, basically. So this is kind of how these things work, that they just cache these things to do and then run on them later. And so the last thing here, so we get all these yes or no, true, false results, and then if they're all true, we append it to the list. So we're just using all. It's very handy. But I know what you're thinking. This is nice and very reasonable and, readable. But can't we do it in one line? Yes, we can. Got a couple of advantages to doing it this way, apart from the readability. Because we're now returning a generator, and because the for statement in statements is being used in the if all, that means if the first statement is false, we never call the second statement. So actually, there technically would be a performance improvement there. But I know what you're thinking. That very silly, very silly. So I think I've gone through that very quickly, but we now have the ability to get the data out. So what does the data look like? And this is all what you're waiting for, because this is where you're going for lunch. Yeah, we get a list of places nearby. I mean, this data wasn't very clean, and some of these are probably not even restaurants. But so the ORM, it doesn't work exactly like every ORM you probably use in the real world. We only sort in ascending order because I've not handled that. The model class I've not shown you has a little magic, because the properties you define in the class then find out what they're called by, you can use a meta class or just hard code it in the init somewhere, but you get to tick off meta classes now on your bingo if anybody's playing. So is this useful? Well, no, I've wasted your time. But I hope you have a better understanding how they work, and maybe it might be useful if you were trying to mock out your database. I'll leave that to you. But if you do want to play with it and see how the code works, I have put it up on GitHub. So it's running 3.6. I have my Apache license there, as everybody should know to use. And feel free to play with it and let me know what you think. Thank you.